Hello everyone, I'm recording this lecture for the 2025 October 20th Monday class because we didn't have our professor to teach us. Okay, so this is the lecture material that I will be doing for the Monday class that we missed. Okay, so 6.4.4 Infiltration Index. So the concept of infiltration in hydrology is that when rainfall occurs, part of it infiltrates into the soil and the rest becomes surface runoff. The infiltration curve represents the rate at which water enters the soil over time. Exact infiltration behavior is difficult to determine because it depends on initial soil moisture, land use, and rainfall variability. So challenges in estimating infiltration are: infiltration decreases over time as the soil becomes saturated. So what that means is that as rainfall continues to come, if this is soil, it starts to fill up with rainfall until it's saturated. Okay, until the soil is full of water that no more water can further go into the soil and it starts just flowing like that. Okay, so rainfall intensity and infiltration capacity vary due to rainfall duration, distribution, vegetation, soil conditions, and wind. Because of these uncertainties, the true infiltration curve is hard to estimate accurately. So infiltration methods. To simplify analysis, empirical indices are used to estimate average infiltration loss. So these are the rainfalls that infiltrate the soil and then get lost. They don't get to run on the surface. They go infiltrate the soil, and then we use indexes to draw a line, to draw a standard and determine how much of rainfall gets lost in infiltration and how much of rainfall counts as direct runoff as it runs off along the surface. Okay, so these indices assume a constant average infiltration rate during a storm event. Yes, so it'll be like a line like this because we assume it's a constant average infiltration rate. Most useful in flood runoff analysis where rainfall duration is moderate to long and infiltration stabilizes. So the two common infiltration indices are the phi index and the W index. And as you can see in figure 6.18, hydrograph and infiltration rate curve. So if the infiltration curve F is placed over the rainfall hydrograph, the portion above the infiltration curve, so the portion above this curve, becomes surface runoff, and the rainfall volume under the infiltration curve becomes the infiltration amount during the rainfall duration. However, since rainfall infiltration begins at the same time as the rainfall, and because the initial conditions vary, it is difficult to determine the exact infiltration curve. Therefore, we use infiltration indices to get approximate estimate. Okay, so we have the actual infiltration curve. So that's effective rainfall by F. So every part of hydrograph that's above this line is which is marked by the left hatching, I guess. And then we have everything that's above this phi index line. That's effective rainfall by phi index. Okay, so every hydrograph that's above this phi index line is direct runoff, and everything that's below is loss. And then we have this one particular area that's both part of both above phi index and the actual infiltration curve F. Okay. Okay, phi index method. The phi index method is used to determine the infiltration loss or direct runoff from a watershed. So infiltration will be everything that's below. So infiltration loss will be everything that's below the phi index, and then direct runoff will be everything above the phi index line from a watershed during a rainfall event. In this method, the average infiltration rate is assumed so that the total direct runoff, which is the effective rainfall volume above the infiltration curve in the rainfall hydrograph, becomes equal to the observed direct runoff. Thus, the average infiltration rate is expressed as phi index, and phi can be written using equation 6.88. Okay, so we have Q equals summation of from I equals 1 to n, inside the parenthesis I sub I minus phi times delta t, where Q is direct runoff, and then we have n, the number of rainfall intervals contributing to direct runoff, and the I sub I, rainfall intensity contributing to direct runoff during interval I, and then we have phi, average infiltration rate, phi index, and then delta t, which is time interval. So we have W index method. The W index method accounts for initial abstraction D, which represents surface storage, and other initial losses that occur before runoff begins, and it considers only the period during which rainfall intensity exceeds the infiltration capacity. The W index is therefore defined as the average infiltration rate during the time when direct runoff occurs. Since the W index subtracts the initial abstraction from the phi index value, it is generally smaller than the phi index. Okay, so we have the equation W equals F over T sub D, P minus, which F can be rewritten as P minus Q minus D over T sub D. So W is W index, and then P is total rainfall or precipitation, Q is direct runoff, D is initial abstraction, which is combination of interception plus surface storage, and T sub D is duration of rainfall that produces direct runoff. Okay. So example 6.10, during a certain rainfall event, rainfall intensities were observed at 30-minute intervals. So that's delta T. Over a duration of 3 hours as follows. So that should be, the duration will be T sub D. So 1.6, 3.6, 5.0, 2.8, 2.2, 1.0 centimeter per hour. When the direct runoff is 3.6 centimeters. Okay, so that's Q. Okay, and the initial abstraction is 0, so D equals 0. Determine the infiltration using the phi index method and then the W index method. So solution. First, phi index method using the trial and error method. When n equals 1, I sub 3 equals 5 is used to compute phi and its validity is examined. Next, when n equals 2, we use infiltration. Intensity equals 5 and intensity equals 3.6 are used. When n equals 3, intensity equals 5, intensity equals 3.6, intensity 2.8 are used. So what they're doing is, if you remember the equation, this equation, so they're doing the trial and error method to determine which n number works best to find the phi index. Okay, so they're trying n equals 1, n equals 2, n equals 3, and so on, right? N equals 1, n equals 2, n equals 3. But when they're doing this, they're selecting the intensities with the highest numbers first. So when it's only n equals 1, so there's only one interval, so only one rainfall intensity. If you look at the data here, 5 is the highest, right? So when n equals 1, it only use this intensity value to compute phi, and then try to see if it's valid, right? And then when it's n equals 2, it used 5 because it's the highest, and then the next highest is 3.6. So that's why I used 5 and 3.6, okay? And then when n equals 3, it used 5, 3.6, and then 2.8. See? And then finally, when n equals 4, it used 5, 3.6, 2.8, 2.2. So from the highest to lowest, okay? And then so they were used to compute phi. The phi calculated for different n values is compared with q to determine the appropriate n. Okay, so this is because in this equation, when you plug in a certain n value, and then we know the rainfall intensity value, right? I sub I is known, and we know delta t. This was 30 minutes, right? So we know delta t, we know I sub I, we know q. So if you calculate, by plugging in n, and then by calculating the summation of, so if you calculate the summation of these values based on n, right? N equals 1, n equals 2, n equals 3, n equals 4. And if you calculate them and then compare with the q value, and then use the known delta t to calculate on this side, and then compare with the q value on this side, and then you eventually get the phi value at the end. And if you compare this value with the I sub i's, you'll be able to see whether like this one works or not. Okay, so you have to plug this in, n equals 1, so you only have 1 I sub I minus phi value, and then you know q, you know delta t, so you'll end up with phi equals something, and then you have to compare this with other I sub I values, and if you think it makes sense, then you say, oh, I'll use this one. But if it doesn't work, then you move on to next one, okay, and see if this one works. In our case, n equals 2 didn't work, n equals 3 didn't work, so we chose n equals 4, okay. So you see, in this example, n equals 4 is used, and phi is calculated as follows. So I'm going to show you how the trial works, okay, because it says using the trial and error method, okay.